This video will show you how to use the catenate function in APL. Catenate is one of the first primitive functions introduced in the language. The catenate function is represented by the character comma. The purpose of this function is to combine two arrays into a single one. The shape of the final array combines the shape of the two original arrays. Here, an array of shape 3 is catenated to an array of shape 4 to produce an array of shape 7. Here is an example using two APL variables in the session. Variable A is a 3-element vector, and variable B is a 4-element vector. Using catenate, we produce an array of shape 7, a new vector of 7 elements. Elements can be of any type. We can catenate a scalar to any array. Here, a space is first catenated to world, then this new string is catenated to hello. We can also catenate empty vectors. Catenate also allows you to combine two matrices together. In this example, a 3x4 matrix is catenated to a 3x5 matrix to form a 3x9 matrix. Each line in the matrix on the left is catenated to each line on the matrix on the right. Here is a concrete example in APL. Let's define two matrices and catenate them together. The number of lines must be the same, otherwise an error is reported. A matrix can be catenated to a single element or a scalar can be catenated to a matrix. A matrix can be catenated to a vector, but the number of elements in the vector must be the same as the number of rows in the matrix. Otherwise, an error is reported. Two matrices can be catenated on top of each other. The APL character used to represent catenate on the first dimension is called comma bar. This time, it is the number of columns that must be the same. Scalars can be catenated to a matrix just like with comma, and vectors too. But the number of elements in the vector must be the same as the number of columns in the matrix. What about arrays of more than 2 dimensions? Cubes have 3 dimensions. Using comma, we can catenate 2 cubes on the last dimension. Cubes can also be catenated on the first dimension using the comma bar. But what if we want to catenate them on the second dimension? Enter the bracket operator. The brackets are used to specify the dimension on which catenation is to occur. We can do it on the last dimension or on the first dimension, and either symbol can be used. Here is an example in APL. A 3D array, an 8-column cube, is catenated to a 4-column cube, giving us a 12-column cube. A 2-plane cube to a 3-plane cube to give us a 5-plane cube. A 2-row cube catenated to a 3-row cube gives us a 5-row cube. Be careful though. Using the bracket operator is quad IO dependent. You can catenate a scalar to a cube on any dimension. Remember, we can use either symbol when using the bracket operator. You can catenate a three-dimensional array as long as the shape of the other axes are the same. Here are three examples that work and one that doesn't. Arrays of more than 3 dimensions are the same. You can use comma or comma bar with or without the axis bracket operator. Here, a 2 by 3 by 4 by 5, a 4-dimensional array, is catenated on the second dimension with a 2 by 10 by 4 by 5 array. It will produce a 2 by 13 by 4 by 5 array. We can also catenate a 2 by 4 by 5 array to the same 4-dimensional array on the second dimension. And in this case, we get a 2 by 4 by 4 by 5. This is it for Catenate. Not a terribly difficult function to master. Go ahead and experiment in the session. If you don't have an interpreter, you can download one at this address here. If you only want to experiment, go to tryapl.org. And don't forget to have fun.